Alright, let's do an example now to make sure we understand this concept. Find an approximation of the area under the curve y is equal to 2x from 0 to 1 using a left-handed Riemann sum with 10 subintervals. Now this sounds kind of complicated at first, but we can break this down. So first, let's find the width of each rectangle. So we're gonna have delta x is equal to b minus a over n, like I said before, and b would be 1 in this case, the end of the interval, and a is 0, the beginning of the interval, and n is the number of subintervals we're going to be having. So we'll divide by 10. So 1 minus 0 divided by 10 is equal to 1/10, obviously. Next, we're going to calculate the height of the rectangles, alright? So since it is left-handed, that means we're going to be using the leftmost value on the subinterval, alright? So we'll start the subinterval at x is equal to 0, alright? And then we'll increase the x's by the width of the rectangle, right? This intuitively makes a lot of sense. So we'll start at x is equal to 0, right? And the height of that rectangle will obviously be 0. Then we'll go to x is equal to 0.1, that's 0.2, etc., etc. And these are all increasing by a width of delta x, okay? And as you can see, it ends at 0.9 since it's left-handed, and so it'll end at the lower value as opposed to the, let's say, 1 if we were using a right-handed sum, and that would give us an overestimate as opposed to the left-handed, which will give us an underestimate. Finally, add up all of these heights and multiply by the width. Now, you might be wondering why I'm doing that. So, since they all have the same width, you would technically be multiplying each height by the width, right, independently, and then adding it all up to get all the areas of the rectangle, sorry, and then adding them all up. However, you can factor out the width and just add up all the heights first and then multiply by the width, since they all share the same with delta x. So then you get delta x times that big sum there, alright, which adds up to 9. And you get delta x times 9 is equal to 9 times 1/10, which is 9 over 10, okay? So then the area under the line y is equal to 2x is approximately 0.9 from 0 to 1, alright, not from negative infinity to infinity, alright? Now, since this shape would be a triangle if you plotted it, right, since a line, right, and it's at an angle and you're going to have that bounded area will be a triangle, you can find the exact area under the curve. If you use the area of a triangle formula, we will find the area is 1. Now, this is actually, now you can see, compare that to our actual, like, approximation. We got 9/10 and the actual value is 1. So we were only 1/10 off, and that's given for only 10 subintervals. Now granted, this is a very simple shape, right? But if we use more subintervals, right, we would have been even closer, right? So let's say we double the amount of rectangles we use, we should probably be twice as close, which would give us 19 over 20. So the more rectangles used, the closer you get. And if we took a limit as the amount of rectangles and the width went to 0 and the amount of rectangles went to infinity, we would actually get 1. Thanks for watching this short video from EDD Academy. Be on the lookout for our future videos. Hope to see you guys soon. Bye.